Hi, this is Gigi from Kauai Community College. This is a video on basic integration, particularly using U substitution and how we can reconcile different answers when we do U substitution, okay? So suppose you have this problem here and it is asking you to use U equals the square root of X, right? So, well, if U is square root of X, then we know du is 1 over 2 square root of x dx. Here we only have dx on the numerator, so we're going to go ahead and solve for dx. So dx would be 2 square root of u of x dx, du, and then square root of x we know is u. So dx is 2u du. So we deal with that one, that's good. Now, if we know what the denominator is, then we can fully substitute everything in terms of u, right? So since u is square root of x, then x must be u squared, and then x squared would be u to the 4th power. So that the square root of x minus x squared on the denominator there would be square root of u squared minus u to the 4th power. And we know that we can factor out the u squared, right? And then square root of that, square root of u squared would be u. So really we have u multiplied by square root of 1 minus u squared. Now let's go ahead and fully substitute all of these x's in for u, right? So we will have the integral of 2u du over u square root of 1 minus u squared, and that is nice because u divided by u is going to be 1. So really your integral is factoring our constant 2 on the outside, 1 over square root of 1 minus u squared. And when I see this, I know that that is one of those inverse functions, and the integral of that is inverse sine of u plus c, and then you'll have a 2 in the front. So our final answer is going to be 2 inverse sine of square root of x plus c, because u is square root of x. Now we are going to do the same problem, but in this case we will let u be 2x minus 1. Now if u is 2x minus 1, du would be 2x dx. So dx is 1/2 du. That's good because we found out what this is, right? And again, let's go and find out what the denominator is so that we can fully substitute. U is 2x minus 1. Solve for x by adding 1 divided by 2, so that x squared is that fraction square. So then your denominator here now is going to be square root of first fraction plus the second fraction. Minus the second fraction because it's x minus x squared. Now, we know that when we are looking for the sum of two fractions, we would have them get a common denominator. So multiply by 2. On top and on the bottom. Distribute the 2, I will have 2u minus 2. And then I am going to distribute out the u plus 1 squared and the minus in the front. That would be minus u squared minus 2u minus 1. Okay, and we can see that 2u minus 2u is gone. And this is going to be plus 2 minus 1, which is plus 1. So that denominator that we see in our original problem is 1/2. And it's 1/2 because the denominator of 4 gets square rooted out, and that would be 1/2. And then the square root of 1 minus u squared. Okay, so let's go and look at the original problem. Substitute everything in. We would have 1/2 du being the dx, and then this right here being the denominator. 1/2 divided by 1/2 is 1. So we now just have the integral of 1 over square root of 1 minus u squared du. And as we've seen before, that is inverse sine of u plus c. But u is 2x minus 1. So our final answer here is inverse sine of 2x minus 1. Then you would be asking yourself, oh, wait a minute, didn't we get a different answer before? Okay, so how do we reconcile the two different answers? First, we got 2 inverse sine of square root of x plus c. The second, we have inverse sine of 2x minus 1. Well, that's because in the first try, we used u equals square root of x. In the second try, we use u equals 2x minus 1, right? How is that possible that we can get two different answers to one problem? Well, let's see. We can do this algebraically, or we can look at it graphically. So using calculus, if I take the derivative of this and the derivative of that, I would say I should end up with the original problem, right? So let's take the derivative of that. Let y be 2 inverse sine of square root of x plus c. Then dy dx would be 2. Okay, and the derivative of inverse sine is 1 over square root of 1 minus square root of x squared multiplied by the inside derivative, which is 1 over 2 square root of x, and then the derivative of c, the constant, is 0. Okay, now we can see that this divided by that, that's 1, right? 1 over, when I'm multiplying the square root, I can keep the square root the same and multiply the stuff inside. So I would have x times 1 minus square root under square. I will have x there. And that is what we had originally started. dy is 1 over square root of x minus x squared dx, right? So remember, that was the original problem. Okay, on the other side, well, let's go do the same. Let y be inverse sine of 2x minus 1 plus c. Let's go and take the derivative. dy dx will equal to inverse sine. The derivative is 1 over square root of 1 minus u squared, which in this case is 2x minus 1, multiplied by the inside derivative, which is 2, and then the derivative of a constant c is 0. And there is a square right there. Okay, now if we multiply this out, we will have 1 minus 4x squared minus minus is 4 plus 4x minus 1, right? Plus 1 minus 1 is gone. There's a 4 right there, so I can factor out the 4. So dy dx is going to equal to 1 over, when I factor out the 4 and take the square root, I have 2 on the outside. And remember, we were multiplying by 2 over here. So that's going to divide it by that. That is gone. And I will have the square root of negative x squared plus x. So same answer, right? So then we can say that dy is going to equal to, these cancel out, dx. And we can see these are the same. So using different u, you get different variation of the answer, but then when you take the derivative, which is going backward of the antiderivative, you get the original problem. So both of those answers are correct. Now, another way of looking at this is to look at it using a graph. Okay, so hold on for just 1 second. I'm going to go to Desmo and pull up the graph. All right, so looking at the graph here, the first function is 2 inverse sine of square root of x plus c, and I'm going to go ahead and set c to be 2 for now. Why 2? I don't know. It fits the screen. Okay, and then the second one, the blue, is inverse sine of 2x minus 1 plus d. I can't use the same c, so I'm using d. Okay, so that's the blue. Now, first, you would notice that the two functions are exactly the same, right? They're just in different places. So what does that mean? That means that the constant c is different from the constant other c in the two answers. So the constant, that is the difference. And it's okay because the derivative of a constant is 0. So when you go backward, the derivative would be the same, right? So now to really show that, I'm going to go ahead and change my d here so I can show you that they really are exactly the same graph, but differ by a constant. Look at that. One goes on top of the other, right? So it is the constant that is different. But as far as the derivative go, they are the exact same curve. Therefore, the derivative should be the same. And that is how you reconcile two different answers when you are using different methods of integration.